The eyes of man have been glued to the skies since the dawn of time, as he dreamt of exploring the universe. After the moon, which during the 60s was the high point of a frenzied techno-political race, it is now the turn of Mars to take center stage.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe.
Mars is the fourth planet in our solar system. It is part of the family of planets called telluric, along with Mercury, Venus, and Earth. Since the discovery of Mars and its polar ice caps, which were initially thought to be made of frozen water, and therefore synonymous with life, the fantasies, dreams, and fears of this elsewhere have filled the heart of man. We have never ceased working to understand this neighboring planet, notably thanks to research into the potential of water on Mars.
Est-ce qu'il y a de l'eau sur Mars?
Is there water on Mars? The answer is yes. There's a lot of water on Mars, but in its frozen state. There are great reservoirs at the poles, which are in fact under the surface or covered by a few centimeters of sand. We discovered that part of Mars's subsoil is actually almost pure ice, which is not really visible because it's covered by sand, so the planet is water-rich. There's a little in the atmosphere. You can see clouds of frozen water, but it has to be said that it's always water in a frozen or vaporous state, which means that Mars currently seems to be unfavorable to life forms as we know them, because they need liquid water. However, there is another planet, Mars, that existed in the early days of the solar system, more than 3 or 4 billion years ago. And when we look at the Martian terrain dating back to that period, you can clearly see traces of rivers and lakes in the craters that have built up there. So everything indicates that at the time there were lakes, rivers, and maybe even an ocean. This was at a time when life appeared on Earth, because there was liquid water as far as we understand. We can investigate, we can send geologist robots to gather samples, we can look into what may have taken place. Some of these samples are brought back to Earth, and depending on what is found, we can establish that either as liquid water is present, life can develop, a new genesis, meaning that anywhere in the galaxy that water is present, life appears, or conversely, if we don't find anything, that tells us that what happened on Earth was totally unique, because at the time there was nothing happening in the depths of Mars's lakes. It's also possible that we may discover an intermediate stage between life and non-life, which is what we call prebiotic chemistry. This will make a very interesting research subject because we have no more clues about what happened on Earth when life appeared. Perhaps Mars will give us some clues. Even if life never really got going, it may have gone through the early stages. For some 60 years, a variety of space agencies have regularly launched machines with the objective of scientifically studying Mars. Close to 50 space probes, orbiters, landers, and rovers have been sent towards Mars since the early 1960s, with a success rate of barely 50%. The high risk of failure and the astronomical cost of missions to Mars have not stopped man's ceaseless quest for knowledge and conquest. Launched by NASA on the 28th of November 1964, the Mariner 4 probe had the objective of taking photographs of Mars. It made the first flight over the red planet, sending back the first images of its surface, and so the first close-up images of another planet. Launched on the 25th of February 1969, Mariner 6 performed the second flight over the planet and sent back the first close-up pictures of Mars's surface. Despite its success, the Mariner program was eclipsed by another American program, Apollo 11, and man's first steps on the moon. One in 5 of Earth's inhabitants watched live footage of the event. Two years later, the Mariner program restarted. Launched on the 30th of May 1971, Mariner 9 reached Mars on the 14th of November the same year, becoming the first space vehicle to be put into orbit around another planet, narrowly beating the Soviet probes Mars 2 and Mars 3, which reached the planet less than a month later. The war of technology between the two enemy blocs raged on in space. On the 19th of May 1971, the USSR launched its Mars 2 probe. Its ambitious mission was to take photographs of the planet's soil and clouds, study its topography, and measure its magnetic fields. On the 27th of November 1971, the lander crashed, but still became the first man-made object to reach the surface of Mars. Mars 3 was launched on the 28th of May 1971. On the 2nd of December, the orbiter released the lander, which reached Martian soil intact near the Serenum fossae, thanks to its parachute and retro-rockets. Mars 3's lander was the first machine to have landed gently on Mars. However, just 20 seconds after it had deployed its instruments, it broke down, having just had time to transmit a dark and blurred image of the planet. Mars 3's lander had on board a small walking robot dubbed Prop M. It weighed 4.5 kilos and was linked to the lander by a telecommunications cable. It moved around using a pair of skis, but its range was limited to the length of the cable, some 15 meters. The data collected by Mars 3 allowed the creation of a relief map of the surface and provided information about Mars's gravity and magnetic fields. A new American mission, Viking 1, reached Mars on the 19th of June 1976. When the module landed on the 5th of July, the orbiter began to carry out a systematic series of images of Mars's surface. "20 years later, NASA returned to Mars with the Mars Pathfinder, a lander which set down on the 4th of July 1997 at Ares Vallis in the Chrysae Planitia region. To reduce costs, the probes used a simplified technique to reach the surface. No radars, fixed pressure retro rockets, and a system of airbags to arrest the landing speed. The bags, inflated by gas generators 8 seconds before landing, completely enveloped the lander. When deployed, the devices are 5.3 meters across, 4.3 meters high, and 4.8 meters deep. The airbags eliminate the risk posed by the uneven terrain. Landing can take place with a vertical speed of 14 meters a second and horizontal speed of 20 meters per second, coping with rocks around 50 centimeters high. For the first time, a small mobile robot or astromobile called Sojourner was deployed on Mars. It weighed 10.6 kilos, was 65 centimeters long, 48 centimeters across, and 30 centimeters high. It had 6 wheels, which theoretically allowed it a range of up to 500 meters from the landing zone. With the increasing availability of the internet, the public was invited to be part of the adventure. It was a huge success. In one day, Pathfinder's website broke all records with 47 million visitors.
Good afternoon from the CNN Center in Atlanta. I'm Jonathan Mann.
And good evening from London. I'm Hilary Bowker. Coming up on this edition of World News, making contact. Just minutes from now, the Mars Pathfinder will attempt to land on the red planet.
Thanks for joining us. This is one of those moments scientists have been waiting for.
This was in 1997, and Pathfinder was the first mission to return to Mars since the Viking years, more than 2 decades before. In the interim, the internet appeared. That was really the beginning. And it's often said that Pathfinder was the greatest internet event, the first significant internet event with lots of views. Instead of just watching TV, people started taking an interest in an event through the web. This was the first time in '97. Personally, I was already in this job. I'd already been involved in other space missions. So what was extraordinary at the time, for me, was not so much the effect on the general public, I wasn't too aware of that, but the emotion of seeing that first image. The chief camera operator, Peter Smith, was a friend, and so to see this new image, which was very high resolution, nothing like the Vikings, of these big rocks, after a rough landing, because Pathfinder landed protected by airbags, and it bounced up 30 meters at first, well, it was fascinating. But that whole period was fascinating because, at the same time, a new satellite called Mars Global Surveyor was launched. And I have to say that one of my favorite images from that time is the high-resolution map of the topography of Mars that was discovered by a laser altimeter on board Mars Global Surveyor. In 30 days, it delivered the first topographic map of Mars with all the detail, and it was stunning. I still get emotional when I look at it now. Mars Odyssey's principal objectives were to draw a chart of the distribution of minerals and chemical elements on the surface of Mars, and to detect any potential presence of water. Placed into orbit in 2002, Mars Odyssey's mission was a resounding success. It provided evidence of large quantities of ice stored under both poles and a particular abundance of potassium. But it was the Mars Exploration Rover, or MER missions, that provided the most significant information about climate conditions on Mars, thanks notably to their onboard laboratories.
3, 2, engine ignition.
2 missions set off at virtually the same time. Each was equipped with a rover and specific instruments. Each rover weighed around 185 kilos and moved around on 6 wheels, driven by electric energy provided by solar panels. Launched on the 10th of June, 6 months later, Spirit landed in the Gusev crater on the 4th of January 2004. It's a 170-kilometer depression that scientists believe may once have harbored a lake, sometime in the distant past. Spirit used the same landing technique used by Pathfinder, that is, a system of airbags surrounding it and protecting it from impacts. The landing site was named Columbia Memorial Station, in honor of the 7 astronauts who had died a year earlier in the Columbia Space Shuttle disaster. Soon afterwards, it sent its first photos. On the 13th of January, it sent the first panorama based on 225 separate shots taken by Spirit's PanCam that were then digitally reassembled. Spirit was equipped with 3 pairs of cameras used for navigation and several scientific instruments, including a rock-scraping tool mounted on an articulated arm, upon which were spectrometers and a microscope camera. The rover was designed to have a lifespan of 90 Martian days and a range of 600 meters. More than 5 years later, on the 17th of March 2009, it had covered more than 7.7 kilometers. Its last communication was on the 22nd of March 2010. Opportunity set down on the 24th of January 2004 on the Meridiani Planum, in the middle of a 22-meter diameter impact crater called the Eagle Crater. From this location, it took panoramic photographs and examined lots of samples. These new analyses allowed scientists to formulate hypotheses concerning, among other things, the past presence of water on Mars. A week later, the rover made its first moves. It spent nearly 2 months exploring the interior of the crater before emerging on the 22nd of March. It then headed east towards the Endurance Crater, 600 meters from the landing site. Throughout its journey, it sent photos to Earth and analyzed the soil. Its odyssey lasted 15 long years, during which it discovered rocks and minerals that were probably formed underwater. It had covered an area of around 45 square kilometers. Thanks to its high-rise telescope, Mars Reconnaissance Orbiter has charted the face of Mars with a resolution of 20 to 30 centimeters. It also serves as a relay for the important sending of data. The Phoenix lander set down on the 25th of May near the North Polar ice cap. The probe was to analyze the composition of the soil and the atmosphere on the ground. It would collect data allowing the recreation of the water cycle on Mars now and in the past, identify organic and volatile molecules present in the soil, water and methane in particular, so as to determine if this would allow the existence of certain forms of life, and finally, study the climate in this polar region. In 2012, the rover Curiosity, the biggest and most sophisticated yet, landed on Gale, an ancient crater full of sediment which was once underwater. The operation was followed by the world's media, and the general public once more had front row seats. It was 5 times heavier than its predecessors, which allowed it to carry 75 kilos of scientific equipment, including 2 mini laboratories which could analyze organic and mineral components, as well as a laser-activated remote system for identifying the composition of rocks. The laboratories were fed by a sophisticated system for collecting and conditioning samples, including a boring machine. Sophisticated software allowed it to navigate the Martian terrain and perform complex tasks. In 2018, Curiosity discovered traces of carbon-based organic elements in the soil. This was no proof of life in itself, but it had potential. The rover was designed to cover 20 kilometers and was able to climb 45-degree slopes. Inside, launched on the 5th of May 2018, was a geophysicist robot. It landed on Mars on the 26th of November 2018, as part of the first mission entirely dedicated to the study of Mars's internal structure. It was equipped with a seismometer and studied Martian vibrations. Its measurements of geological activity should help us understand how Mars was formed in comparison with Earth. The seismometer also recorded the sounds of Mars.
Pour l'exploration de Mars, côté Europe,
On the European front, there were several Martian exploration missions. The first important one, launched in 2003, was called Mars Express, a small, quickly developed mission, a pan-European mission, with a German camera, a French spectrometer, an Italian radar, etc., etc. The British contribution was not an extra camera, but a tiny lander called Beagle 2. Beagle 1 was Darwin's ship, which gives you an idea of Beagle 2's ambition. It was supposed to land and make observations, a first landing for Europe. So Beagle 2 landed, but it failed to deploy its solar panels, and it wasn't possible to communicate with it, so that was a setback. Luckily, the Mars Express observation satellite was able, thanks to its innovative instruments, to revolutionize our knowledge of Mars. And we should be very proud of our European contribution to Martian science, compared to NASA and other countries. And that was followed by a new mission that was part of a program called ExoMars 2016. In 2016, a new observation satellite was launched called Trace Gas Orbiter, which had a camera and a series of spectrometers, which could make a detailed study of the atmosphere and the weather. This was another great scientific success. Along with the satellite, the probe, there was a new lander that was conceived to really learn how to land on Mars, because a previous attempt had failed. There was an urge to get this right. The machine was designed to take plenty of measurements to improve our understanding of the technology required to set down on Mars. It was named Schiaparelli. It weighed 600 kilos, and it was a splendid machine. It entered Mars's atmosphere and sent back lots of data as it descended. It was protected by a shield, and everything was going well. The parachute was deployed, and then the problem started. There isn't time to tell the whole story, but to cut a long story short, it ended with a 3,000-meter fall, and Schiaparelli crashed. It was a second disappointment for Europe. That just shows how difficult it is. You can only admire the successes of our American colleagues who've successfully landed on Mars on several occasions, and now our Chinese colleagues. Why did Beagle 2 fail? I have to admit that the first commissioned internal inquiry that took place concluded that it was my fault. My contribution was to provide models of the Martian environment to establish when the parachute should be opened and so on. The first British commission concluded that it was down to the models I'd provided, so it was a bit embarrassing. I soon realized they were talking rubbish, and we were able to refute their allegation. And the ESA and the British government's final report concluded that there were 3 good reasons for the setback, and the 4th conclusion was that it wasn't because of the models, and therefore not my fault. On Thursday, the 30th of July 2020, the Mars 2020 mission was launched from Cape Canaveral. On board an Atlas V launcher, the rover Perseverance successfully began its great voyage towards the Red Planet. Let's take a look back at the preparatory stages of one of the most ambitious missions in the history of space exploration. Perseverance's primary mission was to collect samples of Martian soil. These samples would be collected by drilling into the soil and then, using an extremely complex mechanism, placed into tubes inside Perseverance. The entire process was subject to one immovable constraint: cleanliness. Every step had to be proof against any potential terrestrial organisms. Despite all the precautions taken during the development of the tubes, a team of researchers still found traces of carbon. The entire production line had to be reviewed, and a new set of protocols developed that would ensure the cleanliness of the equipment. Perseverance obviously had to go through a large number of tests before it was installed on the shuttle, notably rotation tests, shock tests, mobility deployment tests, solar tests, soil sample gathering tests, and transportation tests. Once the tests had been passed successfully, Perseverance was placed in its launch module, which in turn was attached to the rocket which would take it to its final destination, the Jezero crater. The site, which was once a lake, was selected because it was considered to be favorable to the appearance of life, and because of the great geological diversity it offered. Around 7 months after it left Florida, Perseverance reached Mars and began its landing on the 18th of February. What are the 7 minutes of terror? Because of the distance, the reaction times of the instruments, and the necessity for instant reactivity, all of the operations are automated, so Earth has no control over the situation. Any number of problems can strike at every stage. 10 minutes before entry into Mars's atmosphere, the section of the shuttle containing the rover detaches, and the probe enters the atmosphere at a speed approaching 20,000 kilometers an hour. The heat shield helps to dissipate the energy created by friction. The craft slows down. And once it's going sufficiently slowly, the parachute can be deployed. It is the biggest parachute ever used on another planet. A team of NASA geologists determined the ideal spot for collecting the best samples for study, the Jezero crater. The problem being that while this is the most pertinent place, it is also much more dangerous, as its structure is full of cliffs and crevasses. For this reason, Perseverance was equipped with a navigation system that allowed it to scan and analyze the ground below it, and so choose the best landing site with greater precision. As it parachuted down, Perseverance took photos of the ground and analyzed them. As soon as it knew where it was, it jettisoned its parachute and fired its rockets. When it was about 20 meters from the surface, Perseverance was lowered on ropes. On making contact with the ground, the sky crane released Perseverance, and then, to avoid any sudden drop, went and crash-landed a long way from the sampling site. Those are the 7 minutes of terror, but surviving these 7 minutes is just the beginning. Afterwards comes the collection and conditioning of samples to prepare them for returning to Earth. This is the real beginning of the mission. That was the theoretical scenario envisaged by the teams at NASA. These are the powerful images of Perseverance's landing on Mars on the 18th of February 2021.
Applicant indicates chute deployed.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
The images sent back by Perseverance make it clear how expertly the NASA and JPL mastered their craft,
Signals from MRO.
and the extent to which their predictions were correct.
Touchdown confirmed. Perseverance safely on the surface of Mars.
The first phase was the reward for years of work and bolstered hopes of a highly successful mission. To get to this point, Perseverance, which generally resembled Curiosity, was improved, with many scientific instruments specifically designed to look for biological signatures. It was, for example, the first time microphones were used, allowing us to hear Mars's sonic atmosphere. Mars 2020 was also a technological showcase, and Perseverance had two unprecedented experiments on board. MOXIE, a mini laboratory designed to produce oxygen from Mars's atmosphere, and Ingenuity, a helicopter that could confront the atmospheric conditions on Mars. One of Mars's primary resources is CO2, which contains both carbon and oxygen. If the two elements could be separated, it would be possible to harvest oxygen, which would allow humans to breathe and rockets to take off. This gold box may contain the solution. MOXIE works like a reverse fuel cell. Instead of using fuel and producing electricity, the opposite takes place, meaning electricity is used to produce fuel, in this case the fuel being oxygen. The system will have to be heated to a temperature of 800 degrees Celsius for the chemical reactions to take place. MOXIE has been set into a gold casing for optimum thermal insulation and to preclude any interference with the rest of Perseverance's equipment. MOXIE will operate every 2 months, as Perseverance does not have sufficient energy to keep it running continuously. Its priority is to gather soil samples. MOXIE will produce 6 grams of oxygen per hour, which is enough to keep a small dog alive. If the experiment proves to be a success, NASA can launch a specific mission. They would have to send equipment to Mars around 2 years in advance, including solar-powered generators, storage facilities, and MOXIE would have to continually produce oxygen so that humans could then come and use the resource. Ingenuity was the first flying machine on Mars. NASA has planned around half a dozen flights. The idea is to reach an altitude of between 3 and 5 meters and an active range of around 60 meters, and for Ingenuity to take photographs of the Martian surface. The particular conditions of Mars, notably its thin atmosphere, make the creation of such a machine extremely complex. It was necessary to build a machine that was simultaneously very light, but with very powerful turbines to drive the rotor blades at high speed. The whole thing draws its energy from solar panels. Ingenuity was placed underneath the rover and protected by a metal shell. Once released, it took a week of maneuvering to get Ingenuity from its initial horizontal position to one favorable to the separation, after which the rover could move away and let the helicopter take to the air. The rover and the helicopter both have an independent team on Earth, piloting them remotely, and it is their close collaboration that allows operations to run smoothly. The beginning of Ingenuity's mission on Mars was an unqualified success. Since then, it has already made half a dozen flights, going as far as several dozen meters. But these successes are just a stage. The ultimate objective of Mars 2020 is to analyze the samples collected by Perseverance. This presents a new challenge: how to return these samples to Earth. You have to realize that Perseverance is the first stage in a big 3-mission program. So Perseverance collects all the samples from the bottom of the former lake with all its sediment and then puts them into capsules and places them on the ground. The second mission will involve landing on the surface, not far from Perseverance, with a small rover called Fetch Rover, like you say to dogs. This rover will go and pick up the samples, bring them to a little rocket that we call the Mars Ascent Vehicle, and then the rocket will then take off and put a sphere containing these samples into orbit around Mars. If all goes to plan, the little rover should be a European contribution. The European Space Agency is heavily involved in this project. So once the capsule with the samples is in orbit around Mars, a third mission, once again essentially European, will catch the capsule, then place it inside the satellite probe, fire up its engines, and head back to Earth. Once above Earth, the capsule containing the samples will be launched into the atmosphere and make its way down to Earth. And finally, we'll have samples taken from an ocean, or at least a former lake, on Mars. At last, we'll be able to investigate what happened in those lakes 3 or 4 billion years ago. Could there have been life? Are we going to find evidence of any prebiotic biological activity, or nothing whatsoever? The Europeans have provided the third mission with the bus, as we call it, a kind of space probe. The recovery system and the system of capsules that will bring the samples back to Earth is all American. The whole thing is a close collaboration between NASA and the European Space Agency. During 2020, there was noticeable congestion in interplanetary traffic. Because the window was opened for heading to Mars, every nation capable of launching a mission did just that. No fewer than 3 missions were launched. The USA's Mars 2020, China's new mission Tianwen-1, Heavenly Question, and the United Arab Emirates with their Al-Amal, or Hope, mission. On the 23rd of July 2020, China launched its first mission to Mars. Its first attempt had a 3-fold objective, placing an orbiter, a lander, and a rover. On the 15th of May 2021, the Chinese Space Agency's Zhurong rover successfully landed on Mars. 2 initial photographs were made public. This huge triumph propelled China into the realm of the giants of space exploration. A new contestant in the race for the stars, the United Arab Emirates, made a great leap forward when they launched their very first probe, Al-Amal, or Hope. On the 20th of July 2020, the Emirati probe Al-Amal took off from Japan. After a 7-month journey, the probe started orbiting Mars. Its mission was to provide a complete image of Mars's climatic variation, to get a better understanding of its atmosphere and climate. On the 9th of February at 15:30 GMT, Hope began a 27-minute maneuver that consisted of decelerating enough to be pulled into Mars's gravitational field. The hardest aspect of the mission, according to its directors. From the 21st of September 2021, the probe was to begin transmission of information and data that scientists all over the world would have access to. Despite the Schiaparelli setback, Europe planned a new mission to Mars.
ExoMars
2022 is a European and Russian mission, which will launch in 2022 and arrive in spring 2023. It's a highly ambitious mission. We have a very big lander that we're going to set down on its 3 feet. Then we'll lower a European rover that we've called Rosalind Franklin, who was a researcher in the 1950s and was interested in DNA. And we too are looking into possible signs of life. The rover's specific purpose is to head to a very ancient part of Mars, where there's a lot of clay. It's much older than anywhere the Americans have been able to study with Curiosity and Perseverance. The terrain is seriously eroded, but has been heavily impregnated with water. We're convinced of that because of the mineralogy in that area. The rover's going to move around, make a geological study, and we're also going to try to see if we can find any traces of fossils. So what makes our mission so original compared to what the Americans are doing is that we're going to dig for samples, not only on the surface, but deeper down too. Why are we doing this? Because we believe that when rocks have been preserved near the surface for millions or even billions of years, they've gone through alterations, been subjected to radiation damage from the cosmic rays, and to the rather aggressive chemical nature of Mars's atmosphere. There's a lot of hydrogen peroxide, for instance, oxygenated water, which is a sterilizer. And we don't want to sterilize any potential fossil molecules that may have been formed several billion years ago. ExoMars 2022's drill will allow it to bore down to a depth of 1 or even 2 meters. And at that depth, the environment doesn't change very much, but it does offer some protection against the cosmic rays and the aggressive chemical atmosphere. The samples will be brought back to the surface and taken to a micro-laboratory. We have a series of micro-laboratories, in fact. We'll make an infrared analysis, a mass spectrometer, all of the things that you would find in a lab on Earth, but on Mars. And we'll try to see if we can find any clues pointing to any potential historical biological activity. And we'll also use a microscope and other devices to find out what happened on Mars, not now, but 4 billion years ago. In another long-term mission, the United Arab Emirates have an ambition to build a city on Martian soil in the next century, allowing humans to form a colony. In preparation, they want to build a vast scientific city in the desert, close to Dubai, that would simulate conditions on Mars, and so develop the technology necessary for the colonization of the Red Planet. But what was once a closed shop of nations and governments has been entered by a new competitor, the private sector.
When
you think about the private sector's links to Mars, the first thing that comes to mind is, of course, SpaceX and Elon Musk in particular. So we need to clarify things. First of all, SpaceX is quite revolutionary because in the case of missions such as supplying the International Space Station or transporting astronauts, a lot of control was handed to those companies. First, SpaceX, then Boeing, then the Commercial Crew Program. And it gives the impression that astronauts are being transported by a private company. But in fact, it's comparable to what happened before because NASA has always depended on companies like Boeing, Lockheed, Martin, etc. There's also the fact, which is quite unique about SpaceX and Elon Musk, that Elon Musk isn't really driven by money, but more by glory. In fact, he has a dream of going to Mars, taking humans to Mars, even colonizing Mars, so that man becomes a multi-planetary species, to ensure that if there is another catastrophe, humanity will survive. It's a bit early to start thinking like that, but it gives Elon Musk this unique characteristic, which is that he's going to reinvest his entire fortune in this remarkable project. And it makes Mars especially interesting when you look at it from his point of view and SpaceX's. So what will happen in the future? For one thing, are we going to send humans to Mars? It's a good question because we've spent 50 years saying we're going to put a man on Mars in the next 20 years. It's true that partly because the space shuttle is gone and one day we'll get rid of the International Space Station, there will be new ways of getting to the Moon, then Mars. That's what NASA and the European Space Agency are saying officially. But beyond that, you have people like Elon Musk shaking things up and wanting to run before they can walk, saying to NASA, wait, I've got this super-duper rocket for so many dollars I can take the astronauts for you. And at some point, something extraordinary will happen because Elon Musk is driven. He wants to go to Mars. More than ever, Mars is the stuff of fantasy. But now man can almost grasp ways in which this virgin land of promise can be conquered. The future of missions to Mars is, without doubt, bound to be full of discovery and innovation.